Hi, my name is Sam Jett, and I'm a master's student in mechanical engineering. I'm from Coppell, Texas, which is a little suburb by Dallas. After graduation, I'd like to work in the biomedical devices industry, possibly for a small company or startup. I think that those devices can be really valuable and can help to provide information that will help with diagnosis of diseases and to help understanding the link between diseases. I think that my research in the mechanics and structures of tissues in the BBDL has helped to prepare me to better understand how to apply mechanical engineering principles to these bodily processes. Research has been a challenging and growth-filled journey that's taught me many different problem-solving skills. It's a little bit different than in classes. For example, in classes, content is taught from the ground up and you won't be questioned over content that's further advanced than you are in the course. And research is different because you have problems that may have not been solved before, and you have to pull in information from various fields, and it's a very difficult and challenging process. But it's a better reflection of how problem solving has to be approached in the real world. And so I think that my research has really helped me to become a more powerful engineer and to help apply my learning to real world problems. My group's research on heart valve mechanics and structures will help to improve prognoses and treatments for heart valve disease patients. With research in the biomedical field, it's sometimes difficult to see the value of your research as a direct effect to patients. For example, we aren't conducting the surgeries, nor are we designing the replacement valves. What we are doing is building the foundation through these mechanical and structural studies for the next generation of heart valve disease treatments. Our group's work on characterizing the mechanics of materials will be very valuable for future predictive cardiovascular modeling, simulations, and development of tissue-engineered heart valves. Two things come to mind about working in the lab. The first is the people. Through late nights spent in the lab and through attending conferences, I've come to know many good friends. These people are similarly driven and academically minded, and that's been an excellent experience and a chance to meet these people. The second thing I enjoy about working in the lab is the freedom that's afforded to you as a student researcher. If there's a project that you'd like to pursue, you can speak to the professor in charge of the lab, Dr. Chung-hao, and he's very open and receptive to ideas. This is not to say that you need a project or a goal in mind when you join the lab, because there are many projects that need helping hands. But if there's something that you want to pursue, that option is available. And I think that respect for ideas and respect for people is something that's very important and that's very special about the BBDL.